Okay, well, for those that weren't in class today, and for those that just want a quick review of what we were talking about, this is the first problem we did on the quadratic equation sheet with the applications. It was about a baseball player throwing a ball, and the path is modeled by this quadratic equation. As we discussed in class, you have to sort of picture a person throwing a ball, and it somehow goes up and comes down. We know from the equation that because this is the y-intercept, that the initial height was 3 feet. So that's just something to keep in mind. Okay, so the first A asked you when or what the maximum height was, and you can combine this with B, which asks how long did it take or when was the maximum height. And we know that the maximum in this case, and in any case, is always going to be the vertex when our path is modeled by a quadratic equation. So this is going to be when and the height, the maximum height, of that equation. Okay, so we need to know h first, which is a negative b over 2a, negative 20 over negative 32, which is going to be equal to 0.625. And in this case, we have a terminating decimal. So let's use this terminating decimal. Let's not round that off. So if we substitute that into the equation for time, this is time, right? We get a negative k, k, or our y value of our vertex is going to be a negative 16 times 0.625 squared plus 20 times 0.625 plus 3, and if you throw that into your calculator, you'll get that k is equal to 9.25. So we know our vertex is 0.625, that's the time, and the height is 9.25. All right, C, this is A and B. So C asked about how high was the ball after 1.25 seconds. Well, you're just substituting that in, 1.25, because that's the time, and you got to plug it right into your equation. 1.25 squared plus 20 times 1.25 plus 3. And that will give you an answer. Just plug that in your calculator. D, part D asks, when was the ball 8 feet high? Well, if the maximum height is 9.25, 8 feet is somewhere below it. And if we draw a line across at 8 feet, we'll see that there are actually two values. It hits going on the way up, and it hits 8 feet on the way down. So if we set the height, h of t is the height, equal to a negative 16 t squared plus 20t plus 3, we know that in order to solve a quadratic equation, we have to set it equal to 0. So 0 is equal to a negative 16t squared plus 20t minus 5. All right, how do we solve quadratic equations? We now know to use the quadratic formula, in which case A is equal to negative 16, B is equal to 20, and C is equal to a negative 5. Plug those into the quadratic. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and that will give you an answer. You should get two answers. E, the last one, asked how many seconds did it take for the ball to hit the ground? Well, hitting the ground is where the height is equal to 0. So that's that point right there. The other place where the height is equal to here, but that's a negative time, and that doesn't exist in the real world. So we're only interested in the positive value. Once again, height is 0. Set the quadratic equation as it should right there. And in this case, instead of using these values, we're going to use A as a negative 16, B equals 20, and C equals 3. I hope that shows up on the screen. And when you do that, you should get one negative value, which you'll disregard, and one positive value, which you will keep. So when solving these problems, like you do on the other side, having to do with the profit of cooklets, you're always thinking, what is the maximum? What is the minimum? What do I have to substitute in? In the next one, you're given the price of the cooklet and the profit. So you have to make some adjustments on that. But set your axes. It will let you know what you're solving for, and that should tell you how to go through the process. All right. That's it.